I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Millions of people in the US have diabetes. Some don't even know it, and diagnosing the condition typically requires invasive lab work. But now, researchers are making the process much simpler. A team at Penn State have developed a sensor that can detect and help diagnose diabetes and prediabetes via a breath sample. Our breath contains acetone as a result of burning fat. The measured acetone from a person's humid exhaled breath can help differentiate diabetic patients from those who are healthy. The new acetone gas sensor is based on zinc oxide, laser-induced graphene composite with heterostructures on interdigitated electrodes prepared by one-step laser direct writing and simple drop casting. The team has found that their sensor, combined with a molecular sieve coating layer, can accurately detect acetone in the condensation of exhaled breath, and do so without any impact from water molecules found in that condensation. With acetone as the biomarker, the team says the new sensor and related processes facilitate early diagnostics and treatment evaluations. Working toward the goal of addressing the disconnect between information technology and operational technology systems, laser and machine tool manufacturer TRUMPF is joining forces with technology company Siemens. The partnership is meant to accelerate digital manufacturing and AI readiness by elevating industrial production. This will involve bringing together the Siemens accelerator portfolio and TRUMPF's machine building and software expertise. And both companies are now designing open and interoperable IT interfaces to ultimately advance AI readiness for motion control applications. Quantum Computing Incorporated has added to its already substantial funding base with $500 million in gross proceeds via new private stock placement, bringing their current total cash balance sheet to $850 million. The NASDAQ-listed New Jersey startup company now has a foundry in Arizona State University's Research Park, where they develop thin-film lithium niobate photonics. Officials say the additional funding will help with things like accelerating commercialization and expanding the company's workforce. Researchers in California are making strides toward frequency comb advancement with a new device that enables coherent light sources. This technology, developed by a team at the California Institute of Technology that's led by Professor Alireza Marandi, is a nanophotonic optical parametric oscillator, a light source similar to a laser in that they're resonators with optical gain. Specifically, the device facilitates broadband coherent light sources within photonic integrated chips and can produce a broad range of laser light frequencies with ultra-high efficiency on a microchip. The team's work has involved a combination of dispersion engineering, which essentially shapes the way different wavelengths of light move without spreading out, and the optical parametric oscillator designed to efficiently broaden the spectrum while maintaining coherence. Unlike conventional optical parametric oscillators that are bulky and consume large amounts of power, the new nanophotonic version features a sub-micron confinement of light, which produces much higher intensities for the same power. The team says their new device could be valuable for a number of applications, like atomic and molecular sensing, ranging, and communication, computing, and information processing. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.